Now, chapter 15, probability. An experimental approach. Last year, you have had this probability in data handling. You know the basic concept of this probability. Probability means chance. We know every action taking place around us or around the world is an experiment, or every action can be considered as an experiment. And this experiment will have a result. It will have a result. Depending upon this experiment, the result may be different. For example, suppose we read a book. The result is we will get enlightened, or we will get some information or knowledge. If we toss a coin with the faces head or tail, then either the head will turn up or the tail will turn up, assuming the possibility of getting or standing the coin on its edge excluded. So, result is either head turning upwards or tail turning upwards. Suppose we throw a die with the 6 faces numbered from 1 to 6. We will get 1 turning upwards, the side numbered 1 turning upwards, or 2 turning upwards, etc. Finally, 6 or 6 turning upwards. So these are all the results associated with this action or this experiment. And if we repeat this again, then each such repetition can be said to be a trial. If we toss a coin 10 times, then the tossing of the coin 10 times constitute the experiment, and each tossing is a trial. If we read the book 10 times, then the experiment is reading the book 10 times, and each reading is a trial. Similarly, in the case of throwing a die or any other such experiment. And then in the probability or in the chance, we try to make a measurement for this probability, this chance of occurring the result. For every result, there will be a chance, and therefore there will be a measurement, or there can be a measurement for this, but we cannot have, or it will be very difficult or impossible to have a measurement for all the experiments, results for all the experiments. But there are certain type of experiments, certain particular experiments whose results can be measured, or we can assign certain measurements to these results. We will consider here such experiments, that is, the result can be assigned certain measurement known as the probability or the chance. Suppose we read the book 10 times, we will get some knowledge. How can we measure this knowledge obtained? How much amount of knowledge obtained? It's very difficult or impossible. But that is not the case of tossing a coin 10 times. If we toss a coin 10 times, we can have a certain idea in our mind how many times it can be obtained, or how many times tail can be obtained an approximate number. The chance of getting, not exact, we cannot say exact. The exact number of times the head will appear, no, not possible to predict. But normally this coin is assumed to be an unbiased coin, and the chance of occurring each result is equally likely, etc. You know, you are quite familiar. You have seen last year. So, we can think that in tossing a coin 10 times, the number of times head occur can be almost equal to 5. That is, can be 4, 5 or 6. Maybe different, but the feeling we get is entirely different from the feeling when we think of the amount of knowledge we receive in the case of reading a book. It's entirely different. And for such experiments, like tossing a coin or throwing a die, we try to have a measurement for the probability, chance of occurring the result. So there are two ways to measure this probability. One is the experimental approach and the other is the theoretical approach. This year we consider this experimental approach, and next year in class 10 you will see the theoretical approach. So come to the experimental approach. Suppose we want to understand the probability of getting head in a single toss. In a single toss, either we will get a head or we will get a tail. What is the probability of getting a head in a single toss? Since the coin is unbiased, head and tail occurrences of head and tail are equally likely, we may think that occurring these two, tail or head, are of equal chances, and hence in the single toss, half chance to head or half chance to tail, that will be the feeling we receive in our mind. But if we get such a feeling, we cannot take this as the measurement. If we want to express certain measurement, there should be some other reason how we obtained this measurement, this numerical measurement. And this can be done by this experimental approach. This experimental approach says that repeat the experiment a number of times. The number of times, that number can be any. Can be 100, 1000, 10,000, lakh, or any. So repeat the experiment number of times. Watch the number of times head appearing and watch the number of times the tail appearing. Then the probability of getting that result, head, probability of getting the head, which is the experimental, known as the experimental probability or the empirical probability. So experimental probability. Or the empirical probability is defined as probability of, in the case of head, probability of head. This means probability of head turning upwards. Probability of getting this head as the result is equal to number of times head turns upwards. Number of times head turns upwards, or number of trials, number of times or number of trials. Each tossing is a trial. Number of trials head turns upwards divided by total number of trials means tossing. Here it is tossing, total number of trials. That is the case. Suppose we toss the coin 100 times. 100 times. And suppose we get head 45 times and then tail 55 times. Then probability of head, the theoretical probability or the empirical probability of obtaining head is equal to this 45 divided by 100. And that of probability of getting tail is equal to 55 divided by 100. This is experimental probability or the empirical probability. And suppose we again conduct the experiment. Suppose the experiment consists of tossing coin 1000 times. And suppose you obtain, say, head, say, 490 times and tail 510 times. Then probability of head is equal to 490 by 1000 and probability of getting tail is equal to 510 divided by 1000. In the first experiment, 45 by 100. This need not be equal to the probability in the second case, 490 by 1000. It's different. Can be different. But this is the way in which we make a measurement. And that's why it is called an empirical probability. Empirical has the meaning of certain approximation, approximate value, not exact. So that is the probability. In this way, we define this. This is the case of tossing, throwing a die with the 6 faces, 1, 2, 3, 4, 5, etc., 6 faces. To get the probability of getting face 1, conduct an experiment consisting of a number of trials, throwing 100 times, 1000 times, or 10,000 times, or 20,000 times, any number of times. With respect to that experiment, we can have the probability of getting the result. If we throw a die, say 10,000 times, we will get the number turning upwards, say 7,000 or more, so say 1,100 times. 2 turning upwards, say 1,150 times. 3 turning upwards, say 980 times, and so on. Then the probability of getting 1 is the number of times 1 turning upwards divided by total number of trials. Similarly for the other phases also. Okay, and now we know the event. A single result or outcome. This is event, a single result or outcome, or a collection of outcomes is an event. Then similarly we can have the probability of the event. If we denote an event, then similarly we can find the probability of the event E as conducting this type of experiment. Repeat the experiment a number of times. Then total number of trials in which this event occurs divided by the total number of times. Number of times this event E occurs divided by total number of trials, which will give us the probability of that event. So this is the experimental approach to the probability, or the empirical approach to the probability. This will be more clear when we discuss problems in the exercise. So that can be done in the proceeding videos. Okay.